All right, so here we go. We're going to really be looking at some common function graphs. And if I were you, I would definitely memorize the common function graphs. You had to identify them in Algebra 3-4 last year. They're really easy to come up with, but you've got to know what the general function formula is. So for a constant can be anything that's a horizontal line. So like here, I'm going to choose to do f of x is equal to 3. And that's essentially saying y equals 3. And so if I were to plot that, here is 3 on the y-axis. The only way to cut the y-axis into two pieces is with a horizontal line going through 3. That's called constant because it never changes. The y value is always 3. All that can do is go up or down. So if you have f of x equals a number, it's automatically a constant function going through the y-axis at that value. Then we have the identity function. Identity means that x is equal to y. So it's going to look like this. F of x is equal to x because it's really y equals x. So if x is 0, wouldn't y be 0? If x were 1, wouldn't y be 1? If x were 2, y would be 2. Or we can go negative. If x is negative 1, y would be negative 1. X is negative 2, y would be negative 2. This is a common y equals x, a common place for graphs to be reflected over. But it's also called the identity function. X and y are exactly alike. Then one of my favorite graphs, f of x is equal to the absolute value of x. Who remembers what that looks like? It's a v. That's right. And it's a vertex. And again, you can, if you forget these, you just start plugging in points. I mean, I don't ever memorize what the graph looks like, except for I do, because I do it so often, I do know what its general form looks like. But I just start plugging in values for x and y, and I start with x and get y. So if x is 0, the absolute value of 0 is 0. Isn't that the vertex? If x is 1, the absolute value of 1 is 1, so y would be 1. If x is 2, the absolute value of y would be 2. So it almost looks like the identity function, except when x is negative 1, the absolute value of negative 1 is positive 1. Negative 2, absolute value is negative 2. And so, whoops, I just put that up in the wrong spot. Oopsie-doopsies. That's what happens when you're blind. You're blind, teacher. Okay, what mistake is that? Mistake number 6. The people who count. I'm not perfect. I'm just Mary Poppins. I'm practically perfect. All right, so there's your absolute value function. Then, square root. So f of x is equal to the square root of x. What does that look like?
It's like it's only on the x.
Yeah, it's half of a parabola. Really is what it looks like. A parabola that's opening right or left. And so again, plug in some numbers. If x is 0, isn't the square root of 0 0? Now I'm only going to plug in numbers that I can take square roots of. If x is 1, what's the square root of 1? 1. I'm not going to choose 2 because I can't take the square root of 2. Or 3, but I will choose 4. What's the square root of 4? 2. There it is. So those are the 3 points I would be using. It's a curve, and it goes in that direction. And you want some points because we are going to translate these graphs today and reflect them, and you want to be able to have some points with which to translate and reflect. Quadratic, what's the shape of that? What would make my quadratic here? What's the highest degree of a quadratic? X squared. So it's y equals x squared. Doesn't that look like a parabola? And the only parabola that's a function are parabolas that open up or down. Parabolas that open right and left are not functions, so we're not looking at them right now. So if x is 0, 0 squared is 0. If x is 1, 1 squared is 1. If x is 2, 2 squared is 4. And that's as far as I would go on the right. Now go negative. If x is -1, -1 squared is +1. If x is -2, -2 squared is +4. And there's your parabola. Now this is one that you're not quite so familiar with, and this is your cubic, which means that it's f of x equals, what do you think, x to the 3, okay? So let's just put some number values in there. If x is 0, what's y? 0. If x is 1, what's 1 cubed? 1. If x is 2, what's 2 cubed? Okay, let's see if we can fit it on here. 2, 4, 6, 7. It'd be like up to here, wouldn't it? It starts to really increase. So doesn't this go up like this? All right, so let's get the negative part. Because you can't just draw half of the graph, you have to draw the whole graph. So if x is -1, what's -1 cubed? -1. If x is -2, what's -2 cubed? So 2, 4, 6, 7, 8. So it'd look about like this, right? And you're going to learn that odd functions, this is an odd function. Its end behavior goes in opposite directions, and sure enough it does. This is an even function. The end behavior here goes in the same direction. Fascinating. We'll learn more about that later. All right, so we okay with those common functions. So if I were you, I would highlight know your common functions. Because those are the things that we're going to translate and reflect. So then here's the shifts that you need to start to be aware of. I don't really believe in you memorizing a whole lot, but you need to understand what happens. For vertical and horizontal shifts, these are your vertical shifts right here. Vertical shifts, you're looking for some number to be added or subtracted on the outside. This is called the argument. Bless you. This f of x is called the argument. It's just a mathematical term. If it's outside of the function itself, remember that f of x, that function can be different. It could be x squared. It could be x plus 3 squared. But that function itself is the argument. If we're adding something outside of it, we shift up. If we're subtracting something outside of parentheses, is what you're going to actually end up seeing, we shift down. So exactly the same sign. Positive up, negative down. But look what happens when that c is inside the argument, when we have a plus c and a minus c inside the argument. A positive c, or adding a positive number, it does not shift it horizontally to the right. It does it in the opposite direction. Do you remember that from Algebra 3-4? So instead of going right like it seems like it should, it goes in the opposite direction. It goes left. Inside parentheses, opposite sign. Outside parentheses, same sign. You're going to have to figure that out somehow for yourself. Okay? So there's your vertical, horizontal shifts. So let's practice some of those. Can I flip this? Yes? Well, I am. So notice it says no calculators. Now, I'm visually impaired. I have absolutely no spatial talent whatsoever. So some of you may be able to just do this without showing me the original. Most of you are going to need to see the original. So I'm going to put my original in pencil and my new in red. Or I guess I'll put my original in blue. How about that? You'll be able to see it better. So I'm going to put my original in blue. And then my transformation is the one in red. And this is the transformation. This is what we're trying to transform. But what is my common function for this one? What's my common function? F of x squared, right? Mm-hmm. So I'm going to go ahead and draw f equals x squared. And be really, really careful when you do this for me. You need to label your graphs, because if you put both of them on there, I'm not gonna know which graph is which if you don't label them clearly. So this one is f of x equals x squared. I wanna make sure that the person grading this knows what graph is what. Now, what shift is going to occur with the +2 outside? Is it gonna go up, down, right, or left? So we are going to shift up 2. So every point that I just put here, I'm just gonna manually shift each one of them up 2. You can plug it into here and figure it out that way, but it's really a lot quicker just to manually shift every point up 2. The graph should maintain the same exact shape, it just got moved up 2. And so this is x squared plus 2. So look at the next one. This is a cubic. What shift is occurring here? Down 4. And so we are going to go down, shift, down 4. So I'm going to start with my original. My original is at 0, 0, 1, 1. Remember that 2, 8 is off my grid? At some point you're going to have to, for the shift down, you're going to have to do it. So I'm going to go ahead and do 2, 2, 4, 6, 7, 8. I'm going to go ahead and put that one up there. Only because when I shift it down, it's going to end up being on my graph. The left 1, down 1. The left 2, down 2, 4, 6. Now this one, we're not going to shift this one. It'll be way off our graph, won't it? All right, but I'm going to go ahead and connect my curve. And this is f of x equals x cubed. Then shift every point down 4, and these are the 3 most important points right here. I have a lot of kids that will show me the original, and they'll do it with a dotted line. So you could dot your original, and then solid in your final answer. I have kids who'll use colored pens on there. That's fine for this purpose if you do want to do a pen for your original and then your pencil is your shift. But I have to know what your shift is. So there's my shift. And then this is f of x is equal to x cubed minus 4. So these shifts don't change the shape of your graph. Because I'm a terrible artist, okay, it might look like it changed the shape of the graph, but you'll have to go with it. Now we have, isn't this the function f of x is equal to x squared? But don't we have a plus 2 inside? So what shift is going to occur? Because it's positive, we are going to go the opposite direction, left 2. So again, we're going to draw the standard parabola. Once you have that standard, just shift every point to the left to it. The shape did not change, it just moved to the left. Tell me what's happening in the fourth one.
So it's
Left
full
two
up
down.
to mid down one.
So it's left 2, down 1. So your shift is left 2, down 1. Now, some people like to 2, draw 1, and then down 1, draw 1. So you end up with 3 graphs on the same graph. If you're going to do that, just be really, really, really clear that I can see your points and that I know which graph is which. I'm just going to do 2 graphs and do your standard cubic. And then move those critical values. So you feel confident in those? Yes?
Yeah.
Okay. Any questions about those before we talk about reflections? Okay. All right, so then you're going to have some shifts for reflections. So here's your reflections. And all that happens is you either have a negative outside of the main function or a negative inside the parentheses with the x. In other words, everything inside would change signs, or you just change signs outside. So here's some examples of what they might look like. If the negative is outside, it's going to be reflected over the x-axis. Outside x-axis, inside y-axis. Because if you think about it, look what happens. If I have my negative out here, and I choose my value for x, I can choose whatever value I want to for x, right? This negative doesn't really affect my x value that I choose, does it? Doesn't it affect what the y value becomes? Okay? So when it's inside, it affects the y value, so it ends up reflecting over the y-axis. I would suggest that you draw your original, and then for some of you, I would actually input x and y values into this so that you can see what happens. Because for some of you, the reflection is harder than the translation. So here's your general parabola. Now, because the negative is outside, it is going to be reflected over the x-axis. So this should be flipped right down here. For some of you, that should be easy, right? There's no, just look at the distance. Here's your x-axis. If that's your flipping point, how far is 0, 0 from the x-axis? How far is this from the x-axis? 0. So that means when you reflect something that's sitting on the x-axis, it doesn't move. How far is this point from the x-axis? So go 1 in the opposite direction. How far is this point? 1. Go 1 in the opposite direction. And then this point here is 4, so I'm going to go down 4. This point is 4, so I'm going to go down 4. And so there's its reflection. Make sure that you label your graphs. Now, could you have done a table of values for your reflection? Sure. Here's my x. My y is negative x squared. This is my y. So if I chose 0 for x, we plug in 0 into here, we get 0. If I plug in 1 for x, 1 squared is 1, times a negative 1 is negative 1. If I put a negative 1 in for x, I still square a negative 1. Oh, did I write that funny? Yeah, sorry, my parentheses should be out here. So if I square a negative 1, I get 1, then multiply it by a negative, I still get a negative 1. So there's my negative 1, negative 1. And then 2. 2 squared is 4 times a negative 1 is negative 4. And with negative 2. Negative 2 squared is 4 times a negative 1. So if you want to, you can do a table of values if that makes you feel better, and then plot those points. It's all in how your brain works and what's better for you. All right, look at this one. Again, because it's a square to quadratic, I'm going to put my general parabola here. You're going to get really good at these. Interesting, right? So if it's inside, remember if it's inside, it reflects over the y-axis. If this reflects over the y-axis, so this is sitting on the y-axis, this is your point of reflection. How far is this from the y-axis? 1 unit, so go 1 on the other side. How far is this? 1 unit, go 1 on the other side. Doesn't it reflect over itself? Mm-hmm. And I'm going to just prove to you with a table of values. So 0, the opposite of 0 is 0. Squared is 0. Try 1. What's the opposite of 1? Negative 1. Squared, 1. Try negative 1. What's the opposite of negative 1? 1. Squared, 1. So there's your negative 1, 1. And then 2. The opposite of 2 is negative 2. Negative 2 squared is 4. Then try negative 2. What's the opposite of negative 2? 2 squared is 4. So you got that same thing. Question?
Yeah, if you look at it, each of those is looking at squared. So like, if you squared it in number, you're just going to...
Right. Yep. And so I would put here that it's its own reflection. So sometimes it's its own reflection. But notice that I put my visual reflector line in there so I could see where to reflect it, and Mike, you saw it immediately. It reflects on itself, so it can happen. All right, now I'm going to put some graphs on here, and I want you to write the equation. Okay? So we're ready? Can I take that away? All right. So here is your there's the first one. Just write them down, then we'll talk about how to find their equations in a minute. The next one has a point at negative 2, negative 1, negative 1, 0, negative 3, 0, 0, 3, and then negative 4, 3. And then the third one has a point at 3, 0. On a point at 4, negative 1, 5, negative 2, 2, negative 1, 1, negative 2, 0, negative 3. What you have to look at is the vertex for these. Am I correct? Just look at the vertex on all of these. Can I talk without you writing now, or are you still graphing? All right, so if this is the isn't that the vertex of this graph? where should the vertex of that graph normally be? Yeah, it's normally here. So a couple of things have happened. Tell me the shifts that have occurred. So it shifted left 2 and it reflected, right? So it was up here, wasn't it? And it reflected this way. So if it reflects over the x-axis, so I would state, first of all, what shifts occur. So for your reflection over your x-axis, if you look up here, reflection over your x-axis, the negative has to be outside, right? First of all, what kind of a graph is this? What's the general function? Square root. So we have f of x is equal to, because it's reflected over the x-axis, we have a negative out in front of the square root. Am I right? Mm-hmm. And then because we shifted left, is that inside the square root or outside the square root? A shift right or left, is it inside or outside the argument? It's inside. Right and left is inside the argument. So because we shifted left 2, it's also the opposite sign if it's inside. So left is generally negative. So because it's inside, I'm going to do x plus 2. So there's the equation of that graph. Once you get used to it, they're actually a little fun. I like these. Mostly because I conquered the visual. All right, let's look at this. So this is a parabola, right? Mm-hmm. Which is generally a quadratic. Function of x is equal to x squared. Was it reflected? Mm-hmm. No. Was it shifted? Yes. Here's the vertex. Where is the vertex normally? 0, 0. So what are the shifts that occurred? Left 2 and down 2. Just 1. 1. So if I have my f of x, it equals, yeah, if it's left 2, is that inside the argument or outside the argument? It's inside the argument, and because it's inside, and left generally is negative because it's inside, don't we change the sign? So we have x plus 2 squared, and then what do I do with the down 1? Minus 1 on the outside, same sign. Down 1 is negative, outside the argument is always the same sign. Minus 1. Does that make sense? You okay with this? Yes or no, or are you just fuzzy on it? You're not answering me. Does that mean you're fuzzy? What does not make sense? Let me know. It's a matter of putting it all together, am I right? Yeah. So take some time. Doesn't it help if you work with more than one person, meaning more than just yourself? So I would get together and do your homework with several friends, and it doesn't have to be from this class. It could be from all the pre-calc classes, so long as it's not honors, because we all do the same homework. All right, look at this last one here. What kind of general graph is this? Absolute value, right? Okay. So did it get reflected? Yes. Over what? Okay, so it's reflected over x-axis. Is this something that you're going to have to memorize? Probably, yeah. So remember, reflected over x-axis, the negative goes where? Outside the argument. And my argument is the absolute value of x, right? Then what other shift has occurred? This is the normal vertex, right? Right 3. So then we shift right 3. So f of x is equal to, because of my reflection, I'm going to do a negative out in front of the argument of x. And because it's right, it's inside the argument, and it's opposite direction, you're correct. Minus 3. Very good. So see, you're getting better at it already. All right, last page. Because when we're inside the argument, it's always the opposite sign. So since we went to the right, right is normally positive, so we make it negative. If it's up or down, that's outside the argument, then we go exactly the same sign. So up will be positive. So that's just something you're going to have to make peace with in your own brain. Yes. All right, so then vertical stretch and shrink has to do with what I would consider the slope. So these are called rigid transformations. And that's not something I'd make you memorize. But here's our vertical stretch, and here's our vertical shrink. The vertical stretch occurs when C is greater than 1, and notice that C is being multiplied to the function, similar to what we might do with a slope. And here with the shrink, C is between 0 and 1, so it's a fraction. And again, it's being multiplied to the function. So for both of these examples, we've used a absolute value function, only because it's got straight sides. It still works for the parabola or for the cubic. For those, I would definitely be putting values in to a table, a T-chart, and then guess and check. And we're still going to do that with this as well. All right, so our general function would be absolute value, so it looks like this. So this is f of x equals absolute value of x. Then down here, let's do a table of values. So down, or let's do it over here to the left. So x, and then my y is going to be 3 absolute value of x. So if x is 0, what's the absolute value of 0? 0 times 3? Still 0. If x is 1, what's the absolute value of 1? 1 times 3? 3. What if x is negative 1? What's the absolute value of 1? 1 times 3? 3. And we'll do 2 more. I want at least 5 points here. So if x is 2, what's the absolute value of 2? 2 times 3, 6. And negative 2, won't it also be 6 as well? Okay, so plot those points. 0, 0. 1, 3, negative 1, 3. See what's happening to it? So this point right here got pulled up, and this point 2, 6, it got stretched even further. It still has straight sides to it. But look at what happened. A vertical stretch pulls the graph closer to the y-axis. So it just took that graph and went whoop, right up. What do you think the vertical shrink is going to do? It's going to push it down, make it fatter, so to speak. This is skinnier. This is going to get fatter. So again, our general absolute value looks like this. And of course, the better that you know your common functions, the quicker your graphing will be. And so over here to the right, we're going to do our table of values. Now I'm only going to choose values that can be divided by 2. So I'm not going to choose every single point that I put on here. So I will choose 0. Absolute value 0 is 0. And what's half of 0? 0. I'm not going to choose 1 because I can't take half of 1. So I'm going to skip to 2. Absolute value of 2 is 2. Half of 2 is 1. Negative 2. Absolute value of negative 2 is 2. Half of 2 is 1. And let's do 4. Absolute value of 4 is 4. Half of that is 2. And then negative 4. Absolute value of negative 4 is 4. Half of that is also 2. So those are what you want to plot. 0, 0. 2, 1, see how it's getting fatter. Negative 2, 1. 4, 2, and negative 4, 2. So this pulls the graph closer to the x-axis.